Okay, good morning, guys. Just making this video to get you guys going on the 7G notes here. So let's sort of take it away. Um, so here on our 7G notes here, first of all, we have two chords. We have chords AC and BD, and there's something that we're going to see with these chords. The first thing that we're going to do is we're going to connect B and C, and we're going to connect A with D. So we're going to make two triangles here. So B is going to connect with C, and A is going to connect with D. Okay, so we have these two triangles right here. Now, let's say hypothetically arc AB is 72 degrees. Okay, so there's that arc AB is 72 degrees right here. All right, it's going to ask what else must be true. Well, it's something about angles D and angle C. Okay, if we look at angle D, okay, angle D is an inscribed angle and it forms that 72 degree arc. Okay, so we know angle D. All right, going back to I believe it was our 7F notes, is going to be half of the arc that it creates. It's going to be half of that 72, okay? So angle D is half of 72. Well, let's look at angle C. Angle C is an inscribed angle. If we trace it out, it creates the same arc, okay? So we know that, angle D is going to be, half of 72, all right? And angle C is also going to be half of 72, okay? So what's going to happen is angle D and angle C are going to be congruent to each other. All right. So angle D is going to be half 72. Angle C is going to be half 72. So they're congruent to each other. Okay. So angle D is congruent to angle C. All right. And if we come down here and let's say arc DC is 168 degrees. All right. And previously, we did this and this. Does that say something about angles A and B? Well, let's think about this here. So angle A, we trace angle A out. It's an inscribed angle. It's going to be half of 168, okay, because there's a vertex. It creates that arc of 168. So A is going to be half of 168. All right. And if we look at angle B forms the same arc. So angle B is going to be half of 168 as well. So A and B are going to be equal to each other. Okay. So coming here, let's talk about what we have, in total. All right. So we know that just having this deal here, all right, and making these two triangles, okay, we know that angle D is congruent to angle C. Angle A is congruent to angle B, okay? And also we got these vertical angles in the middle right here, okay? So we have two triangles, okay, ADE here and BCE there. These two triangles, now they're not going to be congruent to each other, okay, but they have three pairs of angles that are congruent, okay, so they're similar. They're similar by the angle-angle rule that we did way back early in the year, okay? And that just says if we have any two triangles where they have two pairs of angles that match each other, then the triangles are going to be similar. Okay, similar means same shape, different size, okay? Now, using the four segments, AC, AE, EC, DE, and EB, we can set up a proportion. So let's think about this. AE, okay? AE is a side that's in between the purple and the green, okay? BE is a side that's in between the purple and the green. So we can make a proportion. We can do AE over BE, because those two things are they're not the same, but they correspond to each other. AE is in between these two things. BE is in between the same two angles there, okay? And then on the other side, we have DE and EB. So what's going to happen is that should be East, DE, and we're okay. So DE is between the pink and the green, EC is in between the pink and the green on the other one, okay? So we could say that DE over EC is that, okay? So the proportion of AE to BE, okay, this side to this side is the same proportion as DE to EC, this side to this side, okay? Now, if that confuses you, we just got to go back to our similar triangle stuff, and hopefully the colors kind of help us sort of see, you know, AE is in between these two, and BE is in between those two. You know, it's between the purple and the green, and this is, you know, between the pink and the green, and the pink and the green, so those sort of match up, okay? Now, so we have a proportion, and now if we were to cross-multiply this proportion, we would see something kind of interesting here, okay? Okay, because again, we cross-multiply proportions, and again, we don't have any numbers here, so we're just, you know, sort of talking through this here. We're going to see that AE times EC, okay, is going to equal BE times ED. I'm going to call that DED instead, okay? So let's see what this looks like, okay, in our picture. All right, if I'm looking at my picture here, okay, AE times EC, okay, is going to equal BE times ED, okay? So this piece times this piece is equal to this piece times this piece. And that's called the chord product theorem right there, okay? So the chord product theorem says two chords intersect in a circle, then the products of the lengths of the segments are equal, okay? Products means multiply. All right, so what does that mean? Let's look at number 4 down here. Now, some of these things on here are going to be decimals, but that's okay as long as it matches up. We're cool. Okay. So if we're looking at number 4, this example problem here, there's two chords, PQ and RT. Okay. Now PQ is divided up into PS and SQ. Okay. So on the PQ thing, okay, one piece is the Z and one piece is the 10. Okay. So that's going to be Z times 10 on that one. And on the other segment, RT, it's going to be 6 times 8. Okay? What's going to happen is Z times 10 is going to equal 6 times 8. Okay? And that's the case with all of these, ladies and gentlemen. That's the chord product theorem. Okay? Z times 10 is equal to 6 times 8. Okay? It's coming right across. Okay? So we get 10Z equals 48. And so Z would be equal to 4.8. And that's that. Okay? It's a really, really simple formula there. Okay. Again, you may get some decimals, you may get some whole numbers, but you know, again, it's just follow the formula, and you could always just plug the answers back into the equation and see if they work. Okay. And the triangles that we did up here just sort of show the why of it. Okay. So when we did the angles here with the similar triangles, that's just sort of to prove why this formula works. Okay. And we're going to look at the same thing with our secant thing right here with secant as well. Okay. So take a minute and stop this, rewind it if you need to, pause it, get caught up on the notes, and then we're going to go to the third page here. Okay. So clear the screen. Back to my mouse. Okay. Secant product there. Now this one's a little bit more complex, but the proof of it's a little bit more complex, but the rules are still not too hard. Okay, so we're gonna draw a line connecting D and C. Okay, we're gonna draw another line connecting B and E. All right, so what we have here is we have two triangles. We have triangles ADC and ABE. Okay, so those are our two triangles right there. Now, it's going to ask us, okay, what do we notice about angles B and C? Well, Okay, if I look at angles B and C, okay, angle B is an inscribed angle that creates that little arc DE right here. Angle C is an inscribed angle that creates that little arc. Okay, so angles B and C are congruent. Okay, the same way we saw the other ones that were congruent, on the last thing. Okay, now we have two similar triangles here, and what I'm going to do is I'm gonna take that green one right there, and I'm going to sort of redraw it here to where it's sort of in the same kind of areas here. So we have A, B, and E right there. All right. So I'm going to draw that down there just so we sort of don't really get confused. Oh, shuck. Didn't want to do that. No big deal. All right. So we have ADC, which is this triangle right here. And now we have ABE right there. Okay. Well, both of these triangles have angle A. So angle A, it's congruent to itself, obviously. Reflexive property, if we want to go back to that. And we know that angles B and C are congruent to each other. Okay, so angle C is congruent to angle B. All right. So now what we can do is we can do some proportions again using some of these sides. Now, I don't want to really use E with, hang on. I apologize for that. Do that. Wrong color. I apologize. So we're going to make some similar triangles here using AC, okay, AB, okay, and AE and AD, okay? Because really with these secant lines is what we have, okay? And so what we have is this. We know that AD corresponds with AE. So we can go, AD over AE. All right, is going to equal AC, okay, because that's part of this triangle right there, over AB. All right, again, proportion just like we had before, okay? So in summary, AD to AE, and then AC to AB. Okay, simple. So we were to rewrite that again. When we rewrite proportions, it's to cross multiply. So we get AD times AB is equal to AE times AC. Now let's look back at our picture here, and I want to make a formula that's more words. Okay. So if I'm just looking at these two secant segments right here. All right. AD, which is the outside part of this, times AB, which is the whole thing, equals AE, which is the outside part here, times AC, which is the whole thing. So we really don't use DB or EC. We don't use the inner part of the circle, okay? We use the part of the secant that's outside the circle and the whole secant, okay? So the formula is for two secants, okay? And I'm going to do this in color code here. So outside part times the whole thing of one is going to be equal to the outside part times the whole thing of another. Okay? Outside times whole equals outside times whole. All right, so what does that mean? Let's look at one, and you know what? Let's look at this one over here because this is sort of the hardest one, I think. So let's um, sort of look at that here. So I have two secant segments. I have LN and LS. Okay, LN and LS. So let's say LN I'm going to do in purple here. LS I'm going to do in green. Okay. Now the formula is whole times outside equals whole times outside. Okay. So, or outside times whole, same deal. So if I'm looking at ln, okay, the outside part is 4. Okay, the outside part is 4. The whole thing, well, the whole thing is going to be, and I'm going to write this off to the side, 4 plus x minus 8. Okay, because the whole thing is the outside plus the inside. So 4 plus x minus 8 is really going to be x minus 4. All right. So this whole thing is x minus 4. Okay. Now for LS, this one. Okay. The outside part is 3. The outside part is 3. Now the whole thing, again, I'm going to write this down here, is going to be 3 plus parentheses x minus 5, which really becomes x minus 2. So 3 times x minus 2 is going to be the whole thing. The whole thing is x minus 2. Okay. So we get this equation. 4 parentheses x minus 4 equals 3 parentheses x minus 2. Because again, outside times whole equals outside times whole. All right. So what we end up with is 4x minus 16 equals 3x minus 6. All right. Move everything over. We should get x equals 10. And then we could plug this bad boy back in. Okay. Again, pause the video. Go back if you need to look at the thing. One more time. You have to slow it down just a little bit. But again, we're just following the rule: whole times outside equals whole times outside, or outside times whole equals outside times whole. Same deal. Okay. So now we've gotten the math done, and we get x equals 10. So what happens here? If we get x equals 10, and I'm about to clear the screen, so pause it and write something down if you need to. All right. So if x equals 10, all right, we know that nm right here is 10 minus 8. That's equal to 2. Okay. And if x equals 10, this x minus 5 thing is equal to 5. Okay. Now, what that means is that this whole thing is going to have a length of 6, okay, because it's 4 plus 2. And this whole thing here is going to have a length of 8. Okay, it's 3 plus 5. Now, again, the rule is outside times whole equals outside times whole. So here, the outside is 4. The whole thing is 6. And on this other one, the outside part, okay, the part that's outside the circle is 3. The length of the whole thing is 8. Well, it matches up. 4 times 6 is 24. 3 times 8 is 24. So that's how we get our answer. That sort of works right there. Okay. If this is confusing to you, I would suggest doing, this one, and then those 3 right there, just in case you're having difficulty with it. And again, if we're not sure how to do this, we got to combine like terms for the whole thing. So, for this thing right here, we have to call that 4 plus x. Okay, and the x is really irrelevant after that. And so we just have to sort of combine like terms to get the whole thing before we do that. So again, go back, look at this problem as sort of an example right here on how to do these, and that should be that. And best of luck with these. Last thing I want to talk about is if we have secant tangent. Okay, secant tangent. So if we have, and I'm going to close this out. I'm going to clear that screen. if we have secant tangent, I don't know if we have any of these on here. Here, like this one down here. No, it's not. Never mind. Sorry. All right, so we're looking at these ones like on 9, 10, and 11 right here. Now, the rule still applies where it's outside times whole of one equals outside times whole of another. Okay, so if we're looking here on this green one, the outside is 2 and the whole is 8. Okay, the outside is 2 and the whole thing is 8 because it's 2 plus 6. Okay, so here we have 2 times 8 on this side. What about over here, this tangent segment right here? Well, which part is outside the circle? Well, the part that's outside the circle is z. Okay, that's the length of the thing that's outside the circle. Now, the whole thing, well, there's nothing inside the circle, so the whole thing is also z. Okay, so when we have a tangent segment like that, what we end up with is z squared equals 2 times 8, which is 16. Okay, so the same rule applies. Outside times whole equals outside times whole. Okay, but when that thing is a tangent, when that thing's a tangent line right there, okay, we just square that thing and we equal it to outside times whole the other. Okay, so try these out. I think a good chunk of these will be whole numbers. There may be a few that are not, but again, as long as you check your work, you should be okay. And so that should get you taken care of for the rest of these notes, and we'll go over these as we need to. Okay, thank you very much.